Hello and welcome back to another episode of Getting into GiG-40. Welcome back, Sydney.
Hello.
And today is going to be a little bit off topic. So I don't think we are going to continue with Git Describe in this episode. But it's very relevant nonetheless because during the weekend something cool happened. Because the people from onefetch, they created an issue or discussion in GitOxide with a reference to this: extremely slow with large repositories. And they were bringing up GitOxide here. And I heard the call and I listened and I thought, yeah, that's great. That's perfect. So let's take a look and see if GitOxide could make things faster. And it did some profiling here. It was really, really straightforward. Just run onefetch on some big repository. That's the Linux kernel here. And all this time, 20 seconds or so, it takes to traverse the git commit graph or the commit graph. And I already know that the Linux kernel takes about 7.5 seconds if you do it right with GitOxide. And I thought, yeah, good. So I can definitely be cutting this in half or more than half. And the stuff, the spike here at the end, that's Tokai. Tokai doing essentially this. It gives you language statistics here.
Oh, okay.
And then these are displayed in onefetch as well. So if you use onefetch here, and that's the pre-GitOxide one. So that's the slow one. And we can just, actually, let's run this properly with user bin time LP. So that gives you the time plus memory and all kinds of other statistics, memory peaks and so on. And yeah, now we are right here. This takes a long time just to traverse the commits. And then we do Tokai, and this little nibble here at the end, this is actually nearly a second of deallocating memory because it allocates so many little commits that each commit has a buffer and whatever, maybe even more. And it's deallocating them here. That takes time for millions of objects. And I had some ideas about this, and I thought, yeah, if you play it right, you can be as fast as the slowest operation. And the slowest operation should be about 8 seconds, which is the traversal of the commit graph plus some calculation on it, but not much. And that's the hypothesis that I had. And this is React OS here as big repository. And it actually only takes like 1.5 seconds with the old one. And it's not as terrible, but it has more files, so it's a bit different, the graph there. So here you go. This is the old version, 22 seconds, 23 seconds nearly, and takes 1.6 gigabytes of actually heap allocated memory. That's the second of, destroying all these objects from the heap. Max resident size, I mean, it memory maps a bunch of stuff. This is why it's 2.4 gig. So max resident, that's usually peak, the footprint plus the memory map things.
Right.
Okay, so now I happen to have a path here to a fresh build of onefetch. And we can do that again. This time we can probably look at it because it won't take that long. It's expected, I mean, now with Zoom on and OBS, I'd say 8, okay, 9. No, wait, I think the real value is the one that we have to look at, huh? So 24 seconds, that's real. Yes, 24 seconds, actually 25 seconds for the old one and 9.3 for this one. But if you let it run a little more undisturbed, you get 7.9 let's say 8 seconds on the Linux kernel.
Mm-hmm.
And that's pretty cool because running the estimate hours tool that also traverses the commit graph and does some calculation takes 7.5, 7.6 seconds. So onefetch is just a little bit slower, but also it computes a little bit of additional things. And, you know, one could say, yes, take these 400 milliseconds and I'm good with that. I don't have to squeeze.
Pretty much ideal.
Yes, it's pretty close to ideal like this. And what's also pretty neat is, maybe I said something wrong here. Let's make sure. Yeah, okay, so 68 megabytes this thing now needs. With a max heap size, this should be 900 something. Yeah, so a gigabyte, a max residence size. So because you memory map a pack and some pages of the pack will be loaded as you traverse the commit graph, but not all of them, which means, yeah, the 3 gigabyte or 2 gigabyte pack is just partially in memory then. And let's just look at this peak memory size. Yeah, 1.5 gigabyte. So 1490 by 68, and then the other way around. So 22 times less memory we use.
Yeah.
Or a mere 4.5% of what was used before. So that's pretty cool. And that also removes the issue with the slow heap deallocation at the end, because now there's basically nearly no heap. And those milliseconds you can squeeze out if you say std mem forget to even not deallocate the little memory that you have, but it's probably not worth it to go through that length. At least I'm not going to do it. It's, the maintainability trade-off that you do then, and the code doesn't get prettier when you do mem forget somewhere. Yeah.
So was that something you did specifically for the onefetch repository, or was that some kind of optimization within GitOxide itself?
Great question. It was just standard GitOxide, box standard, so to say, even though, this has been optimized before. But the cool part, the really interesting part, as always, I suppose, is, where is repo? Is when you see the actual usage of Git2 and see how GitOxide would fare if you put that into that place. And luckily, most, if not, I think all of the Git stuff is in the repo module. And, the Git2 repo is still there because I could not yet replace the git config access, because the GitOxide git config doesn't yet use all the git config files that are there, and that makes the result inaccurate. And also workspace status is not yet implemented, but it's getting there, right? That's kind of what I'm working on if I don't do onefetch. Even though it will take some time until that is done. But, the work tree status can also get faster, of course, when you use GitOxide, I presume. And that's going to be faster than Git2. But yeah, that has to wait for another day. But everything else, like the traversal and so on, that's now GitOxide. And yeah, you remember the stats program, huh? It's like, how do you get started with something?
Exactly.
And so that's now, I just switched Windows to GitOxide. So that's stats. And in order to get commit IDs, the traversal here looks like that. So we get the head, then say into fully peeled ID, and then this can be unborn. So we just exit out with that kind of note. Look, a standard string apparently is able to automatically transform into a box doing error. Okay, good. I always have trouble with that, but apparently it does work. Okay. And then you go with ancestors and so on. And that's the alternative. So that bakes the whole unborn thing into one error. which also is specific. And you see it's really just that. And the error ultimately can reflect unborn and will look like this then. So that's something to optimize, but also it will be something to work with. And yeah, I thought that's nice, especially compared to what it was before. So it's not worse at all. And previously the code would create one vector and put all commits in there. It would use git2 commit objects, which ultimately hold a buffer to the commit itself. And that's where all the in Linux case, 1.1 million allocations at least for the buffers, and a big vector that would be built from that. And I changed the algorithm. I did many small steps. So first step, just change one method here and make the minimal amount of changes so that it works like before. So this is multiple steps here taken. And in order to get it even faster, using Git Oxide is basically already half the time of the traversal. And I'm not exaggerating even, I was surprised myself. So the heap allocation, it costs you, but it doesn't cost terrible amounts of time. It costs time, but it's not as terrible as I thought it would be. But if you then see what it really does and then avoid building that vector and just do everything on the fly, this traversal is completely now on the fly, just a traversal, nothing kept except for a hash map of actors, of authors who have been seen in the commit. And that hash map...
Well, you need to pull some information out of the commits, of course.
We look at onefetch here and you see that it tells you which authors have how many commits, and this is exactly what this is good for. So here, hue size, signature, that's this author. Or committer, actually. No, it's the author. What is it? It's the author, yeah, not the committer. Makes sense. And once you do that, you save about 18% of time again. So I made a few in between steps and in between benchmarks to know how much each change is worth, more or less. Two times, 3 times in total. I didn't do the third yet. So these numbers are here. So you see with minimized allocations, we have a massive reduction in peak memory. And we gain 8% on React OS and nearly 20% on Linux. So very, but it's so much more responsive. Like when you don't do all these allocations, it's like it shows when you're not allocating, it shows when you're not deallocating. So it shows twice while the program is running and at the end of the program. And think about it, the end of the program for a non-GC language is in a way like the GC pause, because there you need to clean up, or it will clean up in a memory say, or let's say in Rust, where this is done properly and automatically. I think Git or many C programs, they just exit, and because nothing is done automatically, nobody releases memory at the end of a program, But Rust, C++, they do that. So yeah, there you pay. And it makes sense, but it's also a bit of an annoyance. But something to, it's fair. You have to deal with that. And I was surprised about this for sure. I didn't think it's that small, but that hash map of 30,000 or whatever, how many authors you have, has some size in memory. It's actually pretty big for what it is, but each author also has its own name and email string, and these are also allocated. So if you would optimize these allocations, the overall memory requirements for that kind of data is really low. But the way it's stored is kind of wasteful with small objects and a hash map. So that could probably be like 10 megabytes or so if you intern strings and...
Right, but that would then mean, sacrificing a bit of time, I guess, to keep the memory footprint lower. So what's the high priority?
Yes, but I think it doesn't count. Like, I think it's worth to do that hash map access, absolutely. But you're right. What's the benefit really? Like, is this too much? Maybe one day it is, and then you fix it. But there's potential there. I think for now we're good with 22 times less in one go.
play.
Okay. And is there anything else of interest? Yeah. I think three big things I think I can highlight here in this episode. So that was the four big things I can highlight. So the first one was the performance. We did that. Okay, done. React OS, by the way, started out at 1.5 seconds. And this was the second measurement after minimizing other locations. And after parallelization, now it's at 700 milliseconds. 700 and 1.5, so more than twice as fast as before. And the Linux kernel more than top 2.5 times as fast. So really, really cool. Ultimately, performance, big boost, and Git Oxide is a big part of that, but also algorithm changes and parallelization, like always, right? And I guess Git Oxide swapping that in there is kind of like an algorithm change, because all of a sudden you have the efficiency of Rust instead of having to use libgit2. So, but anyway. And then there are three more things that I want to highlight here. With the second one was this update here with the head commit. And like getting this entry right, like I think this is what I learned here. So head commit can be useful because sometimes you want to start out with traverses like this, and then you want head commit. That's all what you want, and you don't care about anything else. And that's actually a commit object. So you can do more stuff with that, can see what it is, can see the message. So that's all really nice. I updated these commit objects greatly. So now you can just get a lot of stuff directly on the commit object. Parent IDs you can traverse. So that's an iterator, no allocation. All of this is zero allocation now. Committer you can get. So I don't know if you remember, but we did together the message and message raw stuff, which previously would decode. Yeah, it would decode internally. And decode can allocate, because this is a small vec. So if it's more than two parents, it would allocate memory. Otherwise, it actually doesn't allocate. Oh, no, yeah. And if there are extra headers, it will allocate always. But, you know, sometimes you get allocation, sometimes not. But you always parse the whole thing, which, I don't know, might be too much if you really are just interested in some fields, especially when they are on the top of the commit. And parsing is really, really fast. So I thought, yeah, CPUs always get faster, and usually allocations are always slow and you want to avoid them. Allocation, deallocation, mind you. So it's kind of cost you twice. So I thought, yeah, let's always do stuff with iteration. And this is now the change here. So we use the ref iter, and this has now a lot of added methods to basically access the individual fields directly.
So this really only parses to the point where it's necessary, and then keeps going if it would be called again, that it keeps the data. But
great question. Yes and no.
Okay.
Sometimes it's probably nicer to say. Yes and no is a consulting thing, which kind of is annoying. So sometimes it's probably better to say it like this. If you ask for signatures, for example, it parses everything. And I had a version of this where I tried to abort after the parsing is done, but after it has returned what it's looking for, I wanted to stop the iteration. But with filter map, you can't stop the iteration. You can stop the iteration with take until, for example. But what you have then is a closure here and a closure in the other take until thingy that you can chain there. And two closures now have to share memory. And what do you get when you share memory? Yeah, then you have to, because you return an iterator, you now have to return ownership, pass ownership as well. So this state must be owned by two closures. Whether they are part of one object or not doesn't matter here. Rust doesn't know that. So then you have to allocate. You need an RC. And I thought, well, if I do so much to avoid allocations, why would I then allocate here just to abort earlier and avoid the fast parsing? And then
Yeah.
I've undone that, but I did it already. I was thinking, yeah, why didn't I do that before? And this is why I had to relearn what I already knew before. And the other part is when you search individual fields instead of multiple, then it's always easy because you just stop when you found it. And so find map does that, right? So find and map, and once it found it, it's done.
Yeah.
And that's that. And that's pretty cool. Oh yeah, by the way, you also see here, this is not an option anymore. This is results. You remember we kind of changed policies. Instead of squelching the error there, I just return the error.
True.
Decode error. I don't squelch them anymore. That's the rule, the new hard rule, and it's actually okay to do that. It's not a big deal, especially when I was afraid of type parameters being forced upon you, especially when finding objects, because they have a type parameter for the error. But you can always put things into a box and then you don't have to deal with that. And that's how I do it. Because the error case can be boxed, it can be slow, it doesn't have to be raising fast anymore. It should probably be boxed even, so that, boxes can have advantages. Yeah, that's the updates to Git commit. So lots of updates to make it more accessible. And the third thing that is really important because it's your entry point is head ID, right? The new head ID method, same deal. It just gives you an ID instead of a commit.
Okay.
And you remember the commit is something we don't necessarily have. The head can point to commit, but it doesn't have to. So this is the less strict version of it, where you can handle this case too and just get the commit yourself. In this case, they really want to have the object ID in order to get all the references that point to the head ID and that, also new thing, are not a tag. And then we take the name and shorten it. So that you get, just the name of a tag, for example. And that's also new. And then you take the object ID and you shorten it. And that's the short ID, which previously was called prefix. I was sitting here and I was typing what was that? It was called prefix. And I knew we had a conversation about that. And it makes sense. But if I can't remember how to call that thing, I thought, okay, let's put shorten here.
Kind of besides the point, yeah, true. I mean, that makes sense too, I guess.
Yes. And
you can reason about everything.
Yes, you can. It's the thing, it's perspective, right? It's perspective. And we came from just having done the object ID lookup prefix stuff, or the ODB lookup prefix stuff. And then you are prefix, prefix, prefix. Your whole brain says prefix all the time. So it makes perfect sense to call that prefix. And then you see actual user code, and the purpose of this code is to shorten things.
Yeah.
And this is where I introduced the new term shorten as a verb, and name shorten and ID shorten. And it's nice to see that just side by side. It's really, it works. And I thought name shortened, I thought, because I thought name too short. Haha, okay. Then it all is not as good as shortened. So I thought, okay, fine. Because the Rust thing is too short, to something else. That's the typical convention in Rust APIs, but that just reads much better. So that's...
It really does. I mean, looking at this whole section, it's amazing how English it is.
Yeah.
how easily you can read it. Yeah.
This brings me to the next, to the fourth point, the last one. It's a big one too. And it's there's an English sentence in there in this code with 4 words. and it's just perfect English. And it just so happened, so wait for it. Back to this one here. This was a refactor I did. So that wasn't originally, you know, they could have called Git2 ID short ID or whatever. So Git2 can shorten IDs, right? But instead they just converted it to a string and then did the short ID themselves by taking 7 characters off, you know, like hard coding it essentially. And even though that looks correct, right, we do know by now that this is deceptive. It's not actually.
You can't do that.
You can't do that, no. So I thought I took the liberty to say, okay, let's make it like this because that's the intent. And that makes the code on the receiving end much nicer as well. Because this hrefs was then, you know, using this short commit ID twice and was kind of calculating the short commit ID in 2 positions here. Just to show the code that I got to remove. It's really much better now that it's, yeah, so here you see commit string chars take collect. So it's, I mean, this chars take 7, it's a very complicated way of indexing that string, which you can. In this case, it's ASCII, we know that, but yeah, this is in any case preferable over that what was before. And it's correct. And that's the most important thing. Yeah. Okay, back to the perfect English sentence. Let me look for mail map, which is a big new feature. So what's mail maps, you wonder? Mail maps are, let's see if I can explore that a little. So mail maps are just files that can live in many places, but most prominently in the root of the directory. And they look like this. I'm absolutely impressed by the way that BAT is able to highlight mail map files. I mean, this is a specialty format, I'd say, but they do it. Yeah, so it's literally that. And depending, so in this case, just to see 2 examples, this means when you see in a commit this email, set the name to this. So it replaces the name.
Okay.
This means when you see this email, replace it with this email and this name. So see, people might have switched jobs, they did stuff at Intel, and now they want to be privately named and so on. And there is, do we also see another form here? The 4th form. Look in. I hope it's highlighted correctly because then it should be easy to find. Yes, here we have the other form. This one. Or the last form, if you see this email in the commit and this name, replace it with this email and this name. And that's that.
Okay, so it's really just for formatting, and or is that used everywhere, also in the commit messages and yeah?
I didn't actually check. I mean, it's definitely used for displaying commits and commit graphs and when you log stuff. I don't know if it's also done automatically when you create a commit. I don't think it replaces your commit name because that's what you configure, right? That's set, and it doesn't just swap things out under the hood for you. No, I don't think so. But I might be wrong. I didn't look at where it's used. I just know it's used in like 7 places, 7 different subcommands of Git. So it's not even everywhere. It's not crazy.
But Git does this automatically. It just stores this. It just makes this map automatically. Is that a configuration thing?
It picks it up automatically. Yes.
Yeah.
But you can also configure it. So there is the algorithm to get the mail map. It's not trivial. Once again, deceptively simple. It's actually multiple mail maps in different locations that can be merged together into one. So now there's a mail map subcommand. Is this already it? Mail map wasn't. Okay. probably takes a while. Then let's do this. Debug version should be all right. So here there's a now mailmap subcommand that allows you to verify. Oh yeah, that's the wrong repo. So GiG-40 can now fully parse and make available mail maps and do it the Git way. So just for fun, honestly, because I think I need to be able to use this stuff. If I just make a crate and can't really use it, I feel unfulfilled. So I did 2 little commands here, and just smashing these commands, like it's easy peasy, right, nowadays, and that's really cool too. So you can just make these real quick. So this one just verifies any file that you give it, and you can't do anything else with that. Okay, that mail map file is correct. Every line parsed correctly. Let's see what would happen if we put something missing name here, for example. There's no mapping at all. It should find that. Okay, so line 12, missing name, this kind of stuff. So you can finally validate what's going on. But the idea between mail maps is it ignores everything. It loads what it can, it gets what it can, and if there's an error, it doesn't abort. Oh, your mail map is broken. Sorry, you can't log commit anymore. No, it's not like that. It's really very, very flexible. But also Git itself doesn't really show you any errors as far as I know. So it might be hard to actually figure out what's wrong with the mail map if it is wrong. So that's why this is genuine value, I think. It's not at all there yet in Git. It's kind of a niche thing as well. I think the Linux kernel probably has the biggest mail map out there. Maybe, you know, I'd say Google and Microsoft or whatever with the big monorepos, they might also have mail maps, but then again, why? People don't change names, they don't change their email address. Once they're gone from whatever big corporation, they don't change that anymore, right? So it's, I don't know.
In a perfect world, yeah.
So the parser is super fast in the sense of it's 0 copy, and it's kind of state of the art as I do parsers these days. So it's faster than it should be, given that these files are relatively small. It's fun though, it's great fun to implement. So the other version of mailmap is repo mailmap, which is similar, but it doesn't verify, it only lists entries. And the reason there too is that the repo mailmap one, it uses kind of the rules that Git has to load mail maps from different locations. And this is a different mail map potentially depending on your configuration. But also it's auto-configured. This is what repo does. It loads the repo. It needs a repository in the current working directory, and then it uses repo facilities with git config and everything. So it can spit out entries here. And yeah, it just converts this to JSON essentially. And it's a big file. Yeah, I think it can't do anything else. The reason I implemented this is that I wanted to be able to kind of show errors if they happen while kind of building that mail map file, because they're ignored in Git, but they're still, GiG-40 still collects the first error that it sees, and this is being printed. So if there's some big failure there, it will tell you. Yeah. And that's the reason that this thing exists. And yeah, the JSON part is just because I'm lazy and I don't want to do more than just search JSON to write out pretty in order to, you know, get some output going. If I do human output, I always have to do that myself, right? With print now this and that, and who wants that? I don't know. I have no time for that. So does this anything else? No, that's really just that. So that's the mailmap stuff that is available. But now finally for the English sentence, right? I've been letting you wait. So here it is, mailmap resolve commit author. Do you know what it does?
guessing it resolves the commit author.
Yes, you guessed right. And that's pretty cool. Yeah, this mailmap resolve, many iterations again, because there's different variants for this for different purposes. So mailmap resolve is the don't bother me, just do it and do it right kind of thing. And it uses try resolve, which gives you an option. So if nothing was resolved, it's an option here. But if it could resolve the signature and map it in some way, you get a complete copy of the signature with the respective name and or email replaced. But that's allocating, right? So I didn't do anything special to avoid allocations here. But also one could say, if you have a signature ref and you need owned stuff anyway, because that ref is bound to the buffer that is kind of inherently temporary, then most people have to convert this to owned anyway, and now you just pass it through that resolver. In a way, you don't have any extra cost for doing this, because the code previously, it needed an owned signature anyway. So doing this is exactly the right thing and keeps it very simple for the caller. And I think there was one more. Yeah. Try resolve ref, because I couldn't live with myself to say whatever you do, you always have to allocate. So that didn't feel right. So there's this other version that says, okay, give me a ref of that stuff. So it gives you a resolved signature. It's a custom type with just the resolved fields in it. And you can see exactly which one has been mapped. So that gives you the most information for whatever you are doing. And that's also the baseline that everybody uses. And you see this so-called enriched signature, just built given an input signature and then the resolved signature, and then it figures out what to do here. Like sometimes it copies the previous value. Sometimes it uses the new email depending on what's there. So typical, you should see the Git code for that. I mean, the Git does the same, but it's always just pointers and they can be null. So just, honestly, I didn't get it. I didn't get like which gets assigned when. It's so abstract. It's just not jumping at you. But with the match, of course, oh yeah, you've got both, so you use both, right? Okay. Oh, you're just an email, okay. Then take the name from the signature that you get, right? Okay. And the same here.
Always can't be more explicit than that. Yeah. Quite convenient.
It's like, for me, troubled with logic of all kinds. Of course, I need help and hand holding. So here you go. That's the hand holding. And this is supposed to be unreachable. It actually is. This is handled elsewhere, but this is why you say unreachable. This is a bug. This shouldn't happen. And this kind of stuff I usually only do with private stuff, with private code which can have such constraints. That's not usually for production. I mean, that's not usually for public APIs where people can throw different things at you that you then have to
happen.
Yes, that could happen, of course. Because I think people can actually, these entries here, these are the things that are parsed. Look, I made it, actually, you see that rarely, but I made it private here. So that cannot be changed. Okay. People cannot just create any entry. But people can create the valid entries. So here you have a method for each kind of entry that you want to that you want to have. I want an entry to change name by email, to change email by email, to change name and email by email, and name and email by name and email. Because that's also, those who are logically impaired, they read the Git mail map documentation. Safari, really. I don't like you. I still use you because I like others less. So here it's this, like, it's nice, it's well explained, so to say, and it's correctly explained, and you get all the things. But I always had to, it didn't speak to me. I really had to think hard to understand what the cases really are, to truly understand it. And this thing here was just me while reading the docs. I wrote this, It's like, it's changed name by Ema, right? Okay, is this? Okay. And that's it, right? Yeah, that's it. That's all it can do. Okay, good. Deal. I will only use this from now on so that I don't mix things up. I mean, you can always mix something. I didn't want to have these bugs. So yeah, this kind of forced
Okay,
me.
that makes it super clear. It's really easy.
Yeah. It's I can't, I really like to highlight this, but it's my own inability, so to say. Or I don't know, maybe it's an ability and I just play this low, but it's my inability to to quickly understand complex things. So I have to always break it down into simple things that I can understand. And I think the individual's capacity for this varies widely, but having a low capacity, relatively speaking, allows me to do this kind of stuff, which ultimately really maps very well to the problem and really helps you to build up more complex things on top. And I think that's the right way to do it. I mean, certainly there are other ways, but for me, it feels like that's how it should be done. And it felt really nice to do this because of that. There's complex stuff, you don't really get it. Okay, break it down. And it worked. And then there is the parsing, which is fun. It's basically a bit of copy paste, like the basic frame is copy paste from Git attribute parsing and Git ignore parsing. These parsers are implemented as an iterator over lines. So this is why it's called lines.
Oh, okay.
And as you create this one, you give it some bytes. So you fully load the file into memory and then use the ASB string lines. And lines gives you lines, and it does it quickly. This is, this kind of line parsing is really, really fast because Burn Sushi, the mastermind behind ripgrab, did it. So if somebody knows how to parse lines, it's this guy. So this makes me very happy always to use this lines iterator because I know it's awesome. And if it's not, I can probably just create an issue and say, hey, it's not the fastest. And it will be the fastest next morning or something like that. So very, very easy to work with that. So you see, just keep the iterator here. And that's part of your state. So each time you call next, you consume a line and you deal with it. And then in the actual next call, you see it's an iteration over lines because some lines might be skipped. And as you skip lines, you just go to the next. This is why this is a loop. And it naturally ends if there are no more lines. So it looks very natural. Just, it's a very nice way. I like it, let's say. I like it so much I did it 3 times by now like this, or maybe more. And I forgot about it. Actually, I did it all the time. I have a lot of iterators for parsing. Also git commit ref iter, right? It's the same thing. Parses a commit step by step, which is part of the...
I guess that works specifically well because every line is self-contained, right? You don't need to... Yes. It's not much information that's across lines. It's just one by one.
Yes.
It's really simple.
Yes. Yeah, it's perfect. It wants to be parsed like this. And that also deals Windows and Unix line endings and so on. Oh, interesting. I don't do the bomb yet. That's an oversight. The byte order mark. Usually I skip byte order marks that might be in that file, but here I don't. I think there's a reason for that. But yeah, I think the reason is, no, I just forgot. That's the reason. Okay. Anyway, the Git also doesn't do the byte order mark thing, so I don't do it. But technically, every file that somebody writes might have a byte order mark put there by the editor, so you should probably skip it. So Git is a bit inconsistent as it doesn't do that for every file. But anyway, I wanted, I extend the format where I can. So if I can be more flexible, I am. Also, Git only doesn't know Windows line endings here. I think Git only knows. yeah, but I think anyway, whatever, it probably works for Git as well. So yeah, skip lines that literally begin with a hash, and there's no special escape logic or so. And you are allowed to trim these lines, so that trim is also implemented by bstring, so it's going to be fast. And I was lazy, so I just used this. It uses regex automata under the hood, which is a separate crate. And usually I try to avoid putting in extra crates. It's a feature you can deactivate, and then you don't have trim. So you then have to implement it manually by skipping over bytes, which, yeah, I didn't feel like it. Since I checked, I do use in Git object, I do use trim a lot, and there the feature is activated. So since it's activated somewhere in the tree, it's activated for the whole tree of dependencies.
Exactly.
So I thought, it's okay. Who's going to use main map separately, and who's going to be bothered by compiling one crate more? I don't think it's worth optimizing for that, but I thought about it. For the record, I thought about it. Okay. And then, oh yeah, I mean, matches are great. They're really awesome. You see, it works by parsing the name and the email twice. If you can't parse, it's an error. Because it's up to 2 pairs of name and email, right? This is why it's done like this. So you take the line, you parse the first name and email, and you get the rest.
Okay, the rest, yeah.
And then you parse the rest, and you get that, and there shouldn't be anything left over. If it is, then there's an error. And this stuff here, it's all options. Even though not every combination is valid, I mean, not every combination is valid, some are. And if they are, then you create just the right entry for just that case. And that's it. That's parsing. It's done. And parse name and email really just uses these brackets to find where the email starts, and then by that it knows where the name ends. And this is how it knows how to parse this. And yeah. And that's that. And I think it's
So you don't do any special, like, I don't know, checking that the email is valid and whatever. I'm not going to complicate it, just checking for when does it end, checking for spaces in between probably, and then you know what should be where.
It's a good question. I mean, would you want to validate the email? And
maybe it's not even validating the email, but like characters that are not allowed, for example, because it's always supposed to be in a specific format, right? First the name, then the bracket, and maybe if there's a number in there somewhere, you think, no, that's not allowed. I mean, you can get very, very specific there, I guess, with kind of trying to restrict everything. For me, it's always hard to say where to draw the line with this kind of stuff.
Yeah. I was very mindful about this. I mean, Git does it like that. So there's these 2 layers again. There's first the encoding, and Git doesn't care. It just wants to have some ASCII characters in there that it can know. This is ASCII encoded, essentially, if you do this. And that's all Git wants. And then it just sees bytes and treats it as bytes. And if that's still valid encoding, like UTF-16, if you do that with UTF-16, what's happening here? I think out comes some stuff that isn't valid UTF-16 anymore, because you take half a byte away from that UTF-16 encoded thing. Not going to work. But Git doesn't care, so I don't do either. So just don't do UTF-16 here. Second layer is validation. Encoding one thing, Git doesn't care, but kind of assumes ASCII plus UTF-8 sometimes. Not here though. In path, it does assume UTF-8 actually. And then validation. Yeah, but what should you validate? You just trust the user, so to say. And if the user used an invalid email before, then you have to allow it to be the map source so that you can map to a valid email. So you can't really reject stuff. And it's interesting, this, because there is no value associated with validation of any sort with this. It really should just be able to map stuff, and that's the value. And we call that email here, but it's just a bunch of bytes, and that's enough for the purpose. If this would be a list of future customers that we want to, send emails to, we would probably do some more validation. But it isn't.
True. But even then, that's not the job of the parser, right? That just kind of tries to get it into a format that you can then later validate.
Yeah, that's also how I would do it. Then I would definitely not validate in the parser. I would probably do that later. And wrap that in a type. So there's just some B strings here. I guess once you have a validated email type, then it's something you can use. But yeah.
Exactly.
And that's Git mail map. And I think that's already, that's all there is to it, except for how is it actually going to be, how is it used? Like, how do you load a mail map? Yeah, you load a mail map by creating a new empty mail map. And then you load the mail map into this snapshot. It's a mail map snapshot. It's a mail map snapshot because you read stuff from disk once, and then if the disk changes, you don't see that, right? So this is why I call it snapshot. It's something that is quite common in Git speak as well. Like in their code, they have that notion of a snapshot for the same reason.
Okay.
It's not associated to a file on disk. It doesn't stay up to date. It's just an instant in time. Where
the data at the time of creation.
Yeah, at the time of reading, yes.
Yeah.
And you load it. I mean, this is weird, but I thought about this. Like, you would expect this. This is usually what you would expect. Like, you just load a mail. I mean, oh, I can't undo this because I'm actually okay. Can't undo this with Git because it doesn't know it's Git. Okay. This is what you expect, but under the hood, it actually calls this thing here. And there you would expect just, I mean, you don't expect there to be two methods, let's say. That's the thing I tried to say. There should only be one. But if you only have one, then you either get a good result and no error, or you get an error and no good result. But you also don't get intermediate results that way. And that's something that Git explicitly can do.
Yeah.
And this is why the whole error handling story is a bit of an ordeal here, because no error is really terminal. You only ever record the error. So here's some error. And if something important fails, I record that in the error and continue. And it's all like, if this worked, then do something, otherwise don't. And
yeah, just go as far as you can and try to keep all the information that you get, and then just give me something.
Yes, give me something, otherwise put it into error. I don't know why I don't find it anymore. Yeah, it's also quite a lot. And here you see where it loads from. Let's see if we can figure that out here. Actually, let's just look at the docs. So it reads the .mailnet file in the top of the repository of the working tree, if there is one. Like we saw, that's the one on disk. Or read it from the tree directly. So the tree at head, and this is actual valid syntax. This is a ref spec, which allows you to point to a file at a particular commit. That's cool, isn't it?
Yeah.
You're going to implement
That's
ref specs.
awesome.
Yeah, and then learn everything about that, because Git can do so much magic. Unbelievable. Command line, very powerful just because of these little tiny cool things. And this is done if there is no working tree, or if mailmap blob is, if mailmap blob is not set. Mailmap blob, that's a configuration key. And you can just point it to any kind of blob in the repository. And then you read and this is all kind of coming on top. I try to use and or here, but I think it doesn't make much sense. The code is more important there. Like what's stacking on top of each other, right? That's really the question.
Yeah.
I don't think it's not fully, it's written here, but it's probably still hard to understand. I don't understand that right now, what is what. But yeah, it does read from mail map blob if it's set, or it reads from here, but it only reads this blob once. I think this is what that tries to say, because there's always this condition here. So if it's not set, it uses this, otherwise uses this and reads from there. It puts that on top of the mail map that it read on disk. So if you configure a blob, it reads the disk, it reads the blob. If you configure it, or do you? I'm always wondering. I have to check. And lastly, if the mail map file is configured, it reads that as well as a file, and it follows symlinks. So symlinks are otherwise not followed. And so you see there's lots of little details to get right. And I think I did that when I wrote it. I was making sure. That's why I tried to write the documentation as well. So
so you have git config kind of working there already, or it's kind of integrated in this already?
Yes. I mean, that's really the interface we have right now. It's not very convenient or awesome, but it works. And these values are usually local to the repository itself. But if they would come from your user config somewhere else, they wouldn't be picked up. So that's problem is still there. But I just used the config as we have it now, and one day we use something else, and then it will be better, or it will be improved, whatever. You'll see. Okay, so the blob ID here. If there's no work dir, we set the blob ID. If there is a work dir, we try to read the mail map file. And then you see, we copy this into a buffer, keep the error, and parse. That, target, that's the mail map target. And we merge whatever the parser gives us, and we ignore errors. So this parse ignore errors is really just this.
Yeah, literally.
And the parse is just this. So just little utilities that I thought are nice to have for people who do the typical Git stuff that I try to support. So Git ignores errors, fine, so you can parse with ignored errors. This is why I put it here. Otherwise, people could do that themselves, but that felt nice. This is how you do the merging. So yeah, we read the file on disk, and if a blob is set, we put the blob on top. And if the file is set, we read the file. We read the file. And then we ask for the git install dir. Git oxide doesn't necessarily have an install dir, so for now I just use this for lack of something better. Our current. Oh, that's actually wrong. This should be parent. Yeah. Yeah, right. Map. Do you risk assuming that your exe has a directory? I don't, because that's an option. Okay, or else let's lift it up into an error, and this and then does just the right thing. Okay, or else std Oh, error new. Must always be other. It's a bit annoying, you know, there should be a constructor that just gives you a user error or other. Oh, there is one.
That's good design, isn't it?
It is. It's unstable. See, this is why I don't know that. Unstable. Should go to that issue right now and vandalize. Why is this not there? Rustlang / rust / issues. Let's subscribe to that. That feels... it's relatively new, December 2021. Okay, cool. Okay, can't use that, fine. Let me say no parent for executable. Yeah, I think people notice that it's kind of missing this constructor.
A bit cumbersome.
Yeah. Oh. And now, yeah, this is in there. Oh my God. What? Okay, this is in there. So you want to map the parent. I think then we're good. Okay, good. So that's more like it. We use it only in one spot, I think. So we should be able to find where we were by going there. And then, did you know that git config files can actually interpolate the path that you put there? And you can interpolate the git install dir in there explicitly.
Okay.
It's nuts. It's a special syntax. So you do have path interpolation. And yeah, config files, they have a lot of tricks. They can include other files, conditionally include other files. They have different data types and paths are interpolated. So this interpolation context is given here, and then we get an actual path out of there, or there's an error. Okay. And that configured path is then also merged. So 3 files.
Yeah, of course.
The one in the repo, if there is a work tree, the one in the blob ID, if there is a blob ID configured, or if it is a raw, yeah, if it's a bare repository, then we will do that. Oh yeah, that's also interesting, maybe, because it's kind of a cumbersome way of getting the head, is it? Yeah, but okay, fine, I leave it, because now we can do better. Now we have head commit, and this is the long way. One day I'll change that. Okay, and then you get the tree, and then you can look up the path. Options are iterators, and this takes then an iterator of things that can be path components, and then it looks up the path in your tree. So in this case, we only have one. See, sometimes I forget things here. std iter once works, but that is easier, and that was the intent, to let people use some if they just have one thing. And I hope that all builds still. Yeah, and then you get the entry in that tree, and we just take the ID. We do not check what it is. Like, that could literally be a tree. This could be a directory. This could be other stuff. Doesn't have to be a blob, but we don't care. Git doesn't care either.
Because we just assume we kind of know.
The parser will eat everything, right? And it will not fail. So we just, if it's the wrong thing, then we do that. Doesn't matter. Because here we just, what do we do? Where's the blob? Yeah, we just find the object here. See, we don't do anything else with that data. Don't check the type or anything. Just use that. Same is done by Git. yeah, so that was quite a lot of changes overall because the mail map thing was specifically written for onefetch. I think that's also something I could highlight here because it didn't really come out that well. It's the first. Oh, I didn't even mention it here. Jeez, such an understatement. I did that for you, onefetch.
Just for you.
Just for you. And I enjoyed it. It's real cool. And it was working perfectly, fit perfectly into my previous kind of workflow where I did so many parsers anyway, the git attribute parser and the ignore parser. And I thought, yeah, mail map sounds like a fun thing to do, and it was fun. And putting it all together, like seeing it just today, just 1 hour before our session today, I finished the parallelization thing to finally see how fast it can go now. And it's really, really fresh and really, really cool, and really, because that's it. That's now how good it can get. Boom, basic parallelization done. And yeah, that's nearly it with onefetch for the first round. I wouldn't know what else to do except for looking into one tiny little thing. But yeah, no big deal.
Yeah, pretty cool. So this was all the work from your side now, and this will be merged by them after reviewing, or is there a process for that already?
Yeah, I assume. I mean, they know I'm doing this, so I assume. I think during the weekend they're a bit more active. Then the review comes. It's a 1,800 line change. I don't know why it can't be. It's probably most of it is probably a cargo log file or something. Yeah, definitely, because I didn't write so much. It's mostly the same amount of code, if not less. Yeah, here this one. 1,130 lines come from cargo log. There we go. So it's not actually a problem. And the rest is 3 lines here. That also doesn't count. 13 lines author. Did I interpret? Yeah, I interpret that correctly. 13 lines. 20 lines head refs. 2 here. Where's the big one? 56 lines here. Oh, and repo 375. So overall, I think 400-ish lines, not more, of actual change.
Too bad.
Not too bad, yeah. I think that's quite reviewable as a thing, and it just does all the performance. And it's cool. Yeah, I hope it gets merged soon, and I will definitely write about it, or maybe make this PR so nice that you can just post it on Reddit. Maybe I just do that later tonight just for fun. I don't know, maybe I go overboard with this, but I thought, yeah, I think that's pretty cool. And
yeah, I mean, this is like, I don't know how long this took overall, but they wanted an improvement. They got it.
Sunday they said, hey, and I thought, yay, and went right to work. I just finished the thing I was working on. I thought, yeah, that's a cool little intermezzo before I continue with Worktree, which is not so much fun right now, hard and stuff. So this was nice, and also it could be the first step towards greater adoption, right? It's really, that's exactly it. Nice project, nice tool that I use myself, and it's just perfect application and great outcome as well. Like 2.5 times faster for the Linux kernel, twice as fast for typical repositories that are big even, and 22 times less memory, or 5% of the memory usage. I think that's worth having additional dependencies and using libgit 2 alongside git oxide for a while. It's exactly okay. I'll take care of this myself. I can maintain that for them and can update their code as well, as new releases might break things, new major releases anyway. But yeah, it's cool. The first one of hopefully many more to come. like Vergen
Absolutely.
with Git describe.
Yeah, amazing that onefetch came earlier than Vergen now, but
Yeah.
I guess it was just a little bit less work.
Yeah, overall it was easier. It was more straightforward. Most of the stuff was already there, and MailMap was just nails in the wall. And the graph traversal, these algorithm things that we do for Vergen all the time, and like bulk work, it's different, but also different kind of. If you think about how many hours I've put into this, I know exactly, but I didn't check it yet. It's probably 20 episodes or so, maybe 30 episodes even.
Right. Yeah.
So take it with a grain of salt. It's probably quite some work nonetheless, but it feels like less in Vergen. Yeah, cool. But I think that's it for today. Thanks for watching and have a nice day. Bye-bye.
Bye-bye.